Most science fiction assumes alien intelligence visits Earth to strip mine our crust for water or rare minerals. But an interstellar species already has access to billions of dead, ice-filled asteroids. They don't need our raw materials. To figure out their motives, we look at this framework: bleeding-edge Darwinism. We assume an observer possesses extreme technology, cold rationality, and cares strictly about its own survival. We completely strip away human-like morality. A lineage crossing the stars has mastered self-preservation, giving us a concrete baseline. By applying strict mathematical and evolutionary logic to a purely selfish actor, we can derive exactly what a hyper-advanced species requires to avoid extinction. When a biological species reaches extreme technological maturity, it builds a perfect shield. It constructs an environment insulated from disease, predators, and uncontrolled natural hazards. But that total safety triggers a biological trap known as the disease of civilization. By successfully eliminating the harsh filters of a natural environment, the species inadvertently shuts down the external pressures that drive organic evolution. This flowchart maps out the consequence of that success. As a species suppresses environmental pressure, it stops generating spontaneous evolutionary exploration. Its survival becomes completely dependent on its ability to deliberately design and engineer its own future biological adaptations. That dependence creates a severe vulnerability. The species must intentionally invent biological upgrades to survive future crises, but it has no way of knowing what specific environmental challenges it will face a million years down the line. The obvious engineering solution is to build an artificial superintelligence to run simulations and calculate the perfect evolutionary path for every possible future scenario. But there is a hard mathematical limit to that strategy, rooted in the foundational work of Alan Turing and his formulation of the halting problem. The halting problem proves that no algorithm can universally predict whether a given computational process will eventually stop or run forever. This means you cannot build a machine to perfectly pre-compute the final outcome of every complex system. This limit holds true even at the bleeding edge of physics. Principles like Zermelo-Fraenkel incompleteness and the asymptotic spectral gap demonstrate that quantum computers retain undecidable properties. No matter how much energy or processing power an advanced intelligence commands, they remain permanently blinded to the absolute end state of their own evolutionary future. Since they cannot compute the answer to their future survival in a simulation, they are forced to find solutions that have already been generated in the physical universe. That is what makes Earth valuable. It is a 4 billion-year, uninterrupted chain of chaotic, deeply path-dependent evolutionary history. This formula captures the shift in cosmic economics, known as the resource value inversion. It details how extreme technology alters scarcity. For an actor capable of molecular fabrication and deep space mining, ordinary raw matter loses strategic uniqueness. Moving a mountain of iron or pulling hydrogen from a gas giant is trivial, but you cannot manufacture 4 billion years of independent genetic mutation. Earth's biosphere is an empirical witness reservoir, a massive, ongoing biological laboratory that has already stress-tested and solved millions of complex survival problems. That living genetic data represents non-redundant survival options. In a universe where basic elements are infinitely abundant, independent biological information becomes the most scarce asset in existence. This document outlines the resulting Darwinian inversion. Because that biological data is uniquely scarce and essential for their own deliberate adaptation, pure, calculating self-interest mathematically compels a hyper-advanced predator to act as an environmental preservationist. So, how does an emerging, chaotic species like humanity fit into a highly prized biological reserve? Initially, we present a rare dataset. We are an independently evolved technological species, providing a real-time trajectory of how biological organisms transition into a technological lineage. But our recent history alters our status from a biological witness into a systemic hazard. We have developed technology capable of inflicting rapid, catastrophic damage to the entire terrestrial biosphere. The emergence of our nuclear infrastructure crossed a critical threshold. We acquired the power to permanently irradiate or destroy the exact evolutionary reservoir an observing intelligence relies on. An external intelligence monitoring our capabilities is acting on strategic necessity. They are tracking a highly unpredictable hazard that directly threatens a critical data source. If we extend this logic into deep time, we consider that multiple independent technological lineages survived and reached these exact mathematical conclusions. A living world like Earth acts as a convergence node. Independent civilizations arrive to harvest biological data, but their presence creates a new layer of complexity. Because any large-scale conflict can destroy the source they all rely on, the resulting regime is a strategic ecology, a mix of competition, monitoring, and even mutualism. Each lineage becomes an information-bearing witness for the others, making cooperation a more rational survival strategy than war. The cold logic of the computability boundary dictates that survival requires independent data. Ultimately, the most powerful and heavily armed civilizations are mathematically bound to protect the fragile living worlds that produce it.